All right, 8-3, add and subtract rational expressions. Here's the deal. This may seem a little complicated, may seem a little bit tricky, but all this really is the same thing as adding and subtracting fractions. This is just adding and subtracting fractions. So just like when you had to add and subtract fractions back in, what, 3rd or 4th grade, you now need to get common denominators to do it. That's the big trick. So same thing here, right? These ones already have common denominators, so that's easy. This is essentially the same thing as 1 plus 5 over 3 because they have a common denominator. Well, that's 6 over 3, which makes 2. So this one here is the same thing as x minus 5 over 3. And so you're allowed to do this. If the denominators are common, you could just write it as one fraction and combine the numerator however you're told. So here it's x minus 5. If it was plus, we'd write x plus 5. This one cannot be simplified anymore, so that's it. X minus 5 over 3. That's the whole thing. All right, what about this? Again, we can just rewrite it as one denominator, since they're already common, as in 7 plus 5. 7 plus 5 is 12. And then from here, we can actually take out a 3 from each of these. If I take a 3 from 12, I get a 4. It gives me a 1. And so my final answer would be 4 over y squared. Boom. Okay, so that's if you have like denominators. Here's another one with common denominators. We could see that 3x, 2x plus 1, 3x, 2x plus 1 are the same. So again, I can just rewrite it as 9 minus 3 on top, 3x, 2x plus 1 on the bottom. 9 minus 3 is obviously 6. And since this is already factored on the bottom, I can go ahead and see if there's anything that cancels out. And of course, I could take a 3 out of both of these, making that a 2, making that a 1. And so the best answer here would be 2 over x times 2x plus 1. There we go. Now your temptation might be, oh, I have a 2 here, 2 here. Maybe I can cancel out. You cannot, because you have to cancel it out at every term, and there is 2 terms here. There's a 2x and there's a 1. Yeah, it's already factored from the x, but we would have to take it out of both of these, and we cannot take a 2 out of a 1. All right, let's take a look at this one. So at first glance, we would say, oh, they're not common denominators, but wait. We should recognize that as a difference of squares. And so when we multiply those together, we will end up y squared minus 9. So that actually does work as common denominators. So the top I'm going to write as 2y plus 5 over y squared minus 9. And really, there's not much else I can do here. If you wanted to leave it as 2y plus 5 in the factored form over y plus 3, y minus 9, you might want to try that just because it's possible that you'll end up with a binomial factor on top that cancels out. But that's not what we have here, so that's really as simplified as it gets. Okay, that's the easy stuff. That's when you have common denominators or like denominators. But what happens if they're unlike denominators? Well, let's go back to elementary school and remind ourselves, what do we have to do? Well, we have to multiply both by what we think the common denominator is going to be. So 7 and 3, what's the common denominator? Well, they both go into 21. So to get to 21, I'm going to multiply this by 3 over 3. I'm going to multiply this by 7 over 7, right? Whatever the denominator here is, I multiply it top and bottom. Whatever the denominator here is, I multiply it top and bottom. What I would recommend doing is, since you already know what the common denominator is going to be, write one fraction and just put 21, right? Whatever that new common denominator is going to be, just put that on the bottom. Now, what do we have here? We have a 3 times 1, which is 3. I have a plus, and 5 times 7 is 35. And then we would just simplify from here. 3 plus 35 is 38 over 21. I don't believe there's any common factors that we could simplify out there, so we are done. But that was just to remind you about how to add, how to get common denominators and add and subtract fractions when they don't have common denominators. Now let's take a look at this thing. Well, same idea. Multiply by 3 over 3 and multiply by 7 over 7. What would I have? Well, I would have a 21 on the bottom, and I'd have a 3x minus 35 on top. And that's it. Now, if there was a, like, if I could take a, like, obviously I could take a 3 out of 21 and 3, but 3 does not go into 35. But if it did, let's say it was 36, I could factor a 3 out of all the terms. That would be okay. But in this case, there isn't anything that factors out of everything, so I'm done. All right, let's get more fun. Ooh, what if it's an x in the denominator? Well, no big deal. Multiply by x over x, and multiply this one by 3 over 3. Again, the bottom's already set. 3x is the common denominator, so I'm just going to go ahead and put 3x on the bottom. What would be on top? 3 times 4 is 12 minus 5x. I cannot cancel out these x's because I have to cancel it out with every term. So there is nothing that I can cancel out of all these terms, so this is all the way simplified. Let's keep going. All right, now it's getting a little bit more fun. You might want to think about these in prime factorization. What is the common denominator going to be here? Well, obviously a 3 goes into 9, so the common denominator is going to be a 9, or have a 9 as a coefficient. And y goes into y squared, so the common denominator with y's will just be y squared. All right, so in this situation, I'm not going to multiply top and bottom by 9y, and I'm not going to multiply top and bottom here by 3y squared. I'm going to multiply by what I would need to get to this common denominator. And what is that? Well, here, all I would need to multiply is a 3. So I'll multiply top and bottom by 3. And here, all I need to multiply by is a y. And so what do I end up with? Well, 3 times 7 is 21 minus 5y. And there we go. Easy peasy. So again, you got to try to think of what the prime factorization is here. And the prime factorization here, like on this one, is 3y, y. And the prime factorization here is 3 times y. So obviously they have this in common. So we don't need to multiply by that again. We just need to multiply by the leftovers. Hence, y multiplied by 3 and y multiplied by y. Hope that makes sense. I think it'll well the more you do it. Let's do another problem here. Ooh, now we have binomials in the mix. On this one, there is no common factors here, so we're just going to go straight up 3x, 3x. And over here, x minus 4, x minus 4. All right, what I like to do again, let's just think. What would the denominator be? It's just going to be this, right? 3x times x minus 4. So let's just write that. We don't have to actually multiply it out. I would leave it in factored form. It'll make your life easier. What do I get on top? Well, 3x times 9, that's 27x. And then plus, on this part, I would actually distribute 3x minus 12. And the reason I want to distribute there is I have like terms to combine here. So 27 and 3, that makes 30x minus 12 over 3x times x minus 4. Now, what you might want to do here, if you can, is you want to see if there's anything that you could factor out of these two terms on the top, because this is already factored on the bottom. And we might get something that cancels out of both. So let's see. I definitely could take a 3 out of 30 and a 3 out of 12. And if I do that, I would end up with 3 10x minus 4 over 3x x minus 4. And yeah, we could cancel these 3's out once they're factored. I could actually factor a little bit more. I just took the 3 because I saw it was in common. But I could have taken a 6 out of both of those. So let's take a 2 out of both of these just to see if we can do any more. If I take a 2 out, right, that's like 2 times 5, and that's like 2 times 2. So if I take a 2 out, it would be 2 times 5x minus 2 over x times x minus 4. That's really it. There's nothing else that cancels out here because I can't take a 2 out of every term here, and I can't take an x minus 4 out of that. So that's as simplified as we can get. All right, let's do one more here. What do you think your common denominator is going to be? So what we want to do is we want to think about prime factorization here. Remember, y squared minus 9, that's really a difference of squares. So that's y plus 3 times y minus 3. And so they both have a y minus 3 in them. So what else do we need? So we're going to need to multiply this one. It's missing the y plus 3. So we're going to multiply this by y plus 3 over y plus 3. And then this one, we have a 4, so we're missing a 4 over here. So we're going to multiply this one by 4 and 4. When we do that, we already know what the common denominator is going to be, and we'll leave it in factored form. 4, y minus 3, y plus 3. And what do I get on top? Well, 4 times 2y, that's 8y, minus, again, we're going to distribute this, 5y y. Here's something tricky. We have a minus here. I'm subtracting this whole thing. So you might want to think of this as like a -5 that you're distributing. Minus 5y, and then -5 times 3 is -15. Because you're subtracting this entire thing. You're subtracting both of these. So you could have put like a parentheses around this, and it'll be 5y plus 15. Or you can just put minuses on both. All right, now let's see what we can do to cancel out or simplify down. So I have 8y minus 5y. I can combine the like terms there and get 3y minus 15. Again, over 4y minus 3, y plus 3. And now what can I factor out? Well, I could factor out a 3. And if I did that, I would have 3y minus 5 over 4y minus 3, y plus 3. And there isn't anything here that cancels out, so we're done. All right, I want you guys to try this one on your own. Remember, factor both of these first and then see what factors are missing, and that's what you're going to do to find your common denominators. So go ahead and try this one on your own and then unpause the video when you're ready to check your work. All right, so there's a lot of work here. When I broke this down to its common factors, I have 2 times x minus 1. And over here I have x minus 3 times x minus 1. I use the star method to factor that out. So the missing factor here is 2. So I'm going to multiply this side by 2 over 2. And the missing factor here is x minus 3. So I'm going to multiply this by x minus 3 over x minus 3. When you multiply these together, remember to do the box method or FOIL, all your different ways to make sure you multiply correctly. You should end up with this. When you distribute this 2, you should end up with this. And there's a minus sign in the middle. So remember, you're subtracting this whole thing. So I went ahead and just left the minus sign out here. And I'll distribute it afterwards, which is what I do here. So it ends up with plus 4x plus 2. I left it in factored form, and sometimes you'll see me do this. I'm just putting a little quotation symbol here so I don't rewrite the bottom every time because it's not changing. So I'm just kind of making it easy. And when I combine these like terms, I end up with this. And this is actually factorable. So I did a little mini star method over here. I need something that multiplies with the -4 and adds up to 3. And that would be positive 4 and -1. 4 times -1 is -4. 4 minus 1 is positive 3. So we could factor it as x plus 4 and x minus 1. The reason why I factored it is I wanted to see if any of these binomial factors cancel out, and they do. So we have that. Now, probably should say with the restriction that x cannot equal positive 1. Let's add that in there. Remember, we talked about restrictions last time. So just since we canceled that out, we got to keep that in mind. All right, let's move on. All right, now what do we do if we have complex fractions? So let's take a look at method 1. Method 1 is going to be what you're probably familiar with, and that is just getting common denominators on the top. So on the top, right, I would want to multiply this by 3 over 3. Over here, I do 2 over 2. On the bottom, my common denominator is going to be 15, so I'm going to do 3 over 3 here, 5 over 5 here, boom, boom, boom. And we could go ahead and start simplifying this out, right? So on the top, my common denominator is 6, and I have 4 plus 3. On the bottom, my common denominator is 15, and then I have 20 minus 6. And then I can simplify a little bit more. 4 plus 3 is obviously 7 over 6, and then I have 14 over 15. And now I can do what we did last chapter, and that's flip and multiply, right? So 7 over 6 times 15 over 4. And then what cancels out? Well, I could take a 3 out of this, make it a 2, take a 3 out of this, make it a 5. Oh, sorry, that's not 4, that's 14. Take a 7 out of this, make it a 1. Take a 7 out of this, make it a 2. What do I have left? 5 times 1 is 5. 2 times 2 is 4. And that's all fine and good. It's not too bad, but I'll show you another way we could do. I want you to think of the common denominator for everything. So method 2 is, the key here is that you're going to find the common denominator for everything. What do I mean by that? What's the common denominator for 3, 2, and 5? And we have 3 here twice. So 3 times 2 is 6, times 5 is 30. The common denominator we want is 30. And what we're going to do is we're going to multiply everything by 30. And you'll see why here. So what would I get? I'm going to kind of write this out for you so you could see it. But a lot of this you're going to this step that I'm going to do next, you'll probably do in your head. But they would look like this. It would look like 2 times 30 over 3 plus 1 times 30 over 2 over 4 times 30 over 3 minus 2 times 30 over 5. Again, this simplifying that we'll do here, you probably would end up doing in your head. So obviously, what I see here is that this turns into a 10. 10 times 2 is 20. 30 divided by 2 is 15. On the bottom, again, this turns into a 10, but 10 times 4 is 40. And then what I would do here is 30 divided by 5 is 6. 6 times 2 is 12. So really I have 35 over 40 minus 12 is 28. And then from here I could take a 7 out of everything, make this 5 over 4. So you notice it was the same problem, two different ways. The reason why I would recommend this way is a lot of this math right here that I did to get to this step, you can do in your head. Now it might take you writing it out a few times to kind of see, but you can do a lot of this is mental math and you can do it pretty quickly. So we get to this step a lot quicker. And then I think we get to an answer a lot quicker. Now, it's up to you. It's more a matter of preference. I'm going to do method 2, but if you're more comfortable this way, you can do it that way. So let's take a look at how we could do it on a problem like so. Remember, we want the common denominator for everything. This is really like a denominator of 1. So what would my overall common denominator? I have an x, I have a 1. That doesn't really matter. I have a 3x, and I have a 5. So x, I don't need to do another x. 3 and 5, that'd be 15x. So what am I going to do? I'm going to multiply everything, not equal yet, multiply everything by 15x. Okay, what does that look like? Well, I'm going to write out what it would look like for you, but again, this would probably be mental math for the most part. But let's just kind of break this out. What would I have? This would be like saying 2 times 15x over x plus 3 times 15x over 1, but we don't have to write that. 4 times 15x over 3x minus 7 times 15x over 5. Okay, where do we go from here? Well, this is the whole idea. These x's would cancel out, so you really just have 2 times 15, which is 30, plus 3 times 15 is 45x. On the bottom, these x's cancel out, and you could take a 3 out of both of these, leaving you with just a 5. 5 times 4 is 20, minus... Here we can take a 5 out of both of these, leaving you with a 3x. 7 times 3x is 21, so minus 21x. And really, you're pretty much done. Now, you could factor the top. You could factor a 15 out, and you'd be left with 2 plus 3x. But the problem with that is you cannot factor the bottom. So there's nothing that cancels out anyway. So either of these answers will suffice. Pretty nice. Again, the whole goal here is that you're doing a lot of this in your head, so you don't have to actually write out every step. But if it helps, hey, go for it. So let's take a look at this one. What do we think is going to be the common denominator that I can multiply everything by? And let's remember that this is a difference of squares. So this is really x plus 2 times x minus 2. So the common denominator for everything would simply be x plus 2, x minus 2, x plus 2 times x minus 2. All right, so I'm just going to multiply everything by this x plus 2 and x minus 2. Do that on the top and bottom. So not equals yet, just multiply x plus 2, x minus 2 over x plus 2, x minus 2. I'm writing it like this because I think it'll be easier to visualize what cancels. But again, this is the same thing. X squared minus 4 is the exact same thing. All right, so let's try to do this in our head and see what we end up with, right? When I multiply this whole thing by this, obviously the x plus 2's will cancel out. So I'm just going to have a 2 times an x minus 2. Okay, what do I get on the next thing? When I multiply this whole thing by this, remember, x squared minus 4 is the exact same thing as my common denominator. So this will all cancel out with this, and all I have is a 4. Okay, minus. Now what happens when I do 7 over x minus 2 times all this? The x minus 2's will cancel out, and I really will just have a 7 times x plus 2. Well, there's not much more I can do here. I could try to distribute on the bottom. The top is already factored, so that's just 2 times x minus 2. On the bottom, what would I get? I would get a negative 7x minus 14. Let's combine these like terms, 4 and negative 14. I would end up with negative 7x minus 10. And there's not a lot I can factor out from that. Maybe a 1, like a negative 1. And so I end up with negative 1, or just a negative 7x plus 10. But that doesn't really matter because it doesn't cancel out anyway. So really, any of these are fine. There we go. Not too bad. I like the method 2 a lot. If you can just like visualize what cancels out, it makes your life a lot easier. Just cancel out a whole bunch at one time. All right, I want you to try these two. Again, you remember you're going to have to think about the these in factored form, right? These ones are already common denominator, so that's super easy. So go ahead and try these two on your own, or actually, sorry, these four on your own. And then try the method we just used for this one. And for these ones, you're going to need to get common denominators. For this one, you already have common denominators. So go ahead and give these four a shot, and then just check back when you're ready to check your work. All right, let's go over these one at a time just to make sure we understand what's going on. First thing, I want to factor this. This is actually a perfect square. It's x minus 4 times x minus 4. So the missing factor here is just x minus 4. I'll multiply that top and bottom. When I do that, I'm going to distribute this negative 8 to the x minus 4 and gives me negative 8x and positive 32. I can combine these to make negative 23x plus 32. On the bottom, I'm writing it in factored form. This doesn't factor because 23 is a prime number. There's no numbers I could take out of both, so we can just leave it exactly as it is. Next one over here, it couldn't get much easier, folks. We already have common denominators. We're literally just adding 5 and 3, and we get 8. Boom, easy peasy. Over here, we're going to use the second method I showed you guys to cancel everything out. When I multiply, the common denominators here would be x times x minus 2, because I have an x minus 2, and this is already x times x minus 2. So when I multiply this, the x's will cancel out, and I have 3 times x minus 2. When I multiply this, the x minus 2's cancel out, and I just have a 5 times an x. And when I multiply this on the bottom, since this is equivalent denominator here, they cancel out, and I just left with a 6. From there, I just distribute and simplify, and I get 4x minus 3. Here I took a 2 out of every term, just in case you didn't tell. All right, let's go to this one. The common denominator is going to be x plus 1, because this is just a 1. So I multiply x plus 1, x plus 1. Here I get x squared plus x. I rewrote it as x squared plus x plus 5. And I tried to factor it, but this is not factorable. X squared plus x plus 5 is not factorable. So we can't simplify it at all. That's it. That's as simplified as we can get. All right. Hopefully that helps. I'll see you guys on the next video. Don't forget to leave me a question.